Welcome to the deep dive. Ready to take a deep dive into the world of generative AI?
Always ready for a good deep dive.
Looks like you've been digging into some fascinating stuff too, including excerpts from a document titled Generative AI, Intelligent Design.
Yeah, some really interesting stuff.
Our mission today is to understand how these AI systems design new content. Get ready for some aha moments. So maybe we should start with the most basic question. What is generative AI?
Well, at its core, generative AI is AI that creates. It's not just analyzing data. This AI actually makes new content.
Okay, like in this source material that says, imagine AI writing a poem about a sunset or creating a picture from your description. It's kind of like magic.
Yeah, it is a bit like magic, but it's also built on decades of research. It actually started with rule-based systems, then neural networks came along, and things really started evolving quickly.
And then 2014 happened, right?
Exactly. That's when generative adversarial networks, or GANs, were introduced, and they really shook things up.
GANs, yeah. I've heard the term before, but I'm still a little fuzzy on what makes them so special. Can you break it down for me?
Sure. So basically, GANs involve two neural networks competing with each other.
Competing? How does that work?
So you have one network called the generator that tries to create realistic content, and then you have another network, the discriminator, that tries to tell if the generated content is real or fake.
So it's like a game of cat and mouse with the generator trying to fool the discriminator.
Exactly. And as they go back and forth, both networks get better and better.
So that's how those hyper-realistic images and videos are created.
That's one way, yes. GANs have been incredibly successful at generating highly realistic output.
So cool. But why should we care? How is generative AI changing things in the real world?
It's already making waves in so many fields.
Hmm.
Like, for example, in healthcare, they're using AI-generated medical images to help radiologists make more accurate diagnoses.
Wow, that's incredible. Okay, so we've talked about GANs, but the source material also mentions things like machine learning, algorithms, and different types of learning. Can we unpack those a little bit?
Of course. So machine learning is sort of the engine behind all of this. It's how these systems learn from data.
Okay. And there are different types of machine learning.
Right. There's supervised learning, where the AI learns from labeled data. You can think of it like training a spam filter. You give a bunch of emails that are labeled as spam or not spam, and it learns to identify patterns that distinguish them.
So it learns to recognize what spam looks like based on the examples you give it.
Got it. And then what about these other terms I saw in the source, like linear regression and decision trees? Where do those fit in?
Those are specific algorithms that are used in machine learning. They're basically sets of rules that the AI follows to make decisions or predictions. So let's go back to that spam filter example. Linear regression could be used to predict the probability that an email is spam based on certain features, like the sender's address or the keywords in the subject line. So it's like drawing a line through a scattered plot of data points, trying to find the best fit.
Precisely. Now, decision trees are different. Imagine a flowchart where each step asks a question about the data. Based on the answer, you move to the next question until you reach a final decision, like spam or not spam.
So they both help the AI make sense of the data, but in different ways.
Uh-huh.
Okay. Now, the source material really dives deep into the world of neural networks, which seem to be the foundation for a lot of these generative models.
Yeah, that's right.
But it gets a little complex talking about CNNs, RNNs, and transformers. Can we break down those different types of neural networks?
Sure. Think of a neural network as a complex structure, kind of like the human brain, made up of interconnected nodes that process and transmit information. Each type of neural network is designed for a specific kind of task.
Okay, that makes sense. So what are CNNs?
CNNs, or convolutional neural networks, are really good at analyzing visual data, like images and videos.
So those are probably used a lot in generative AI for tasks like image recognition and image generation.
Exactly. Now, RNNs, or recurrent neural networks, are different. They're designed to process sequential data, like text or speech.
Because words and sentences have a specific order, right?
Right. RNNs can remember previous elements in a sequence, which makes them really good at things like language translation and generating text that sounds natural, like in a conversation.
That makes sense. And finally, what about those transformers? They sound pretty powerful.
They are quite powerful. Transformers have kind of revolutionized natural language processing thanks to something called self-attention.
Self-attention. That sounds pretty intense.
Well, think about it this way. When you read a sentence, your brain automatically pays attention to the relationships between different words to understand the meaning. Self-attention allows AI to do something similar. It helps them understand the context and nuances of language, which leads to more sophisticated text generation and understanding.
So it's like they're really focusing on how the words relate to each other, not just processing them one by one.
Exactly. And that's a big deal for natural language processing.
Okay, I'm starting to see how all these pieces fit together. We have these different types of neural networks, each with its own specialty, and they're being used to power a whole range of generative AI models. So, what are some of the different types of models out there? The source mentions quite a few.
Oh, there are tons of different models, each with its own strengths and weaknesses. Some of the main ones include variational autoencoders, or VAEs, generative adversarial networks, those GANs we talked about earlier, and autoregressive models.
Wow, okay, let's break those down one by one. What are VAEs good at?
VAEs are great at taking complex data, like an image, and encoding it into a smaller, more manageable code. Then they can use that code to decode the information and reconstruct the original data.
So, they're good at compressing information and then recreating it. Are they used for generating images too?
They can be, but their output might not be as realistic as some other models.
Got it. And what about those GANs again?
Remember those dueling networks we talked about?
Yeah, the generator and discriminator battling it out to create realistic content.
Right. That's the heart of a GAN. And they've been really successful at generating some pretty amazing outputs.
Okay, so they're the rock stars of image generation. What about autoregressive models? How do those work?
Autoregressive models are great at predicting what comes next in a sequence, like the next word in a sentence or the next note in a melody.
So they could be used to generate text that sounds natural or music that flows smoothly.
Absolutely. They're excellent at that kind of task.
So it seems like we've got a lot of different model types out there, each using different neural networks as their building blocks, and they're all capable of generating different kinds of content.
Exactly. It's a pretty diverse landscape.
Now, there's one particular type of model that the source material highlights: diffusion models. Why are they so special?
Diffusion models have been making a lot of noise lately, especially in image creation. They work in a very interesting way. Imagine taking a clear image and adding noise to it, little by little, until it just looks like random static.
That sounds kind of destructive. Why would you want to add noise to a perfect image?
That's the clever part. Diffusion models actually learn to reverse that process.
What do you mean?
They learn to start with pure noise and then gradually remove it step by step until a clear image emerges. It's like taking a blurry, distorted picture and slowly bringing it back into focus.
So they kind of learn to denoise the image, but in a very sophisticated way. That's pretty amazing. What are they being used for?
They're being used for all sorts of things. Creating super realistic faces, enhancing old photographs, even generating synthetic data sets to train other AI models.
It's kind of like they're taking this destructive process and turning it into a creative tool. Incredible. Okay, so we've gone from the basics of machine learning and neural networks to this whole zoo of generative AI models.
Hmm.
But the source material doesn't just focus on the technology itself, it also talks about how these systems are designed and built.
Right. That's an important part of the process.
So why is that important?
Well, it's easy to get excited about the magic of AI and all the amazing things it can do, but it's important to remember that we're talking about complex systems here. We need well-designed, robust systems to make all of this work reliably.
So it's not just about having a brilliant idea, it's also about having the right tools and a solid plan to execute it.
Exactly. And the source actually outlines the key components of a generative AI system.
What are those components?
Well, first, you have the data pipeline. That's where you collect and prepare the data that the AI will learn from.
Because garbage in, garbage out, right? The AI can only be as good as the data it's trained on.
Absolutely. Then you have model development. That's where you choose the right type of model for your task, you train it on your data, and you fine-tune it to achieve the best possible performance.
So it's a little bit like choosing a recipe and then carefully following the instructions to bake a cake.
I like that analogy. And just like with baking, there are tricks and techniques that can make the process more efficient. The source talks about something called transfer learning, where you can actually take a model that's already been trained on a massive data set and then adapt it to your specific needs.
So you don't have to start from scratch every time. That's handy.
Exactly. It saves a lot of time and resources.
Okay. So we have the data, we've trained the model. What's next?
Well, then you have what's called the inference engine. That's the part of the system that takes your input, whether it's a text prompt or an image, and uses the trained model to generate new content.
Ah, so that's where the magic happens.
Exactly. That's where the trained model actually gets to work and create something new. And finally, you need to figure out how to deploy the system, how to make it accessible to users. That might involve creating an API or a user interface.
So that people can actually use the AI, whether they're developers or just regular users.
Precisely. And it's also important to remember that the work doesn't stop there. You need to monitor the system, make sure everything's running smoothly, address any problems that come up. It's an ongoing process.
So it's not like you just set it and forget it. You have to keep an eye on things and make sure everything's working as expected. Makes sense. Now, the source also mentions a common challenge with generative AI scalability. Can you explain what that means in this context?
Sure, scalability basically refers to a system's ability to handle increasing amounts of data and user requests without slowing down or crashing.
Right, like if a social media platform is using generative AI to create unique avatars for millions of users, you wouldn't want the system to grind to a halt just because a lot of people are using it at the same time.
Exactly. That's a great example. And there are techniques for dealing with these scalability challenges, things like distributed computing, load balancing, and caching.
So basically, finding ways to distribute the workload and make sure the system can handle the demand.
Exactly. It's a crucial part of designing and building these systems.
This has been a great deep dive into the foundational concepts of generative AI. We've covered a lot of ground, from the basics of machine learning to these incredibly complex models. But I'm eager to see how this technology is being applied in the real world. The source is packed with examples and case studies, so maybe next we can explore some of the amazing things that are being done with generative AI across different industries.
Yeah, let's do that.
So, where should we start with these real world applications of generative AI?
Well, we've talked about the visual stuff like images, but this technology is really shaking things up in the world of audio and music too.
Ooh, now that's something I'm really curious about. AI composing music. It sounds so futuristic.
It does, doesn't it?
Yeah.
But it's becoming more and more common. Like this source mentions how people are using AI to generate custom soundtracks and background music for videos.
That would be a lifesaver for content creators. Finding the right royalty-free music can be such a pain.
Yeah, it can be. And the quality of the AI-generated stuff is getting really impressive. There are even platforms where you can specify the mood, tempo, and instruments you want, and the AI just composes a custom piece for you.
A personalized soundtrack. Amazing. What about voiceovers? Could AI be coming for my job there too?
Well, let's just say that AI-powered voice synthesis is getting pretty sophisticated. The source even talks about how podcasters and video creators are already using AI to generate voiceovers. Saves a lot of time compared to recording them traditionally.
Wow, that's kind of mind-blowing. And a little bit scary, to be honest. So AI can do the music and the voiceover. What about sound effects? Those seem really complicated to create.
They can be, but even there, generative AI is making things easier. It can design immersive, realistic sound effects for games, movies, you name it.
So we're basically talking about AI systems that could handle all aspects of audio production.
It's heading in that direction for sure. But I think it's important to remember that it's not necessarily about replacing human creativity. It's more about giving us new tools, new ways to collaborate. Like musicians and sound designers can use AI to explore new sounds, experiment with new styles, push the boundaries of what's possible.
I like that perspective. It's not AI versus humans. It's about using these tools to enhance our own creativity.
Exactly. And speaking of creativity, let's move on to one of the most visually stunning applications of generative AI, art and design.
Oh, yeah. Now we're talking AI art hanging in galleries. AI designed fashion on the runways.
You're not far off. The source mentions how AI-generated artwork is already being showcased around the world. Some of these pieces are so realistic and intricate that it's hard to believe they weren't created by a human artist.
That's incredible. I'm also really curious about the practical side of design, like fashion, for example.
Oh yeah, fashion designers are using AI to create all sorts of things. Textile patterns, whole clothing collections. It's a great tool for experimenting with different styles, pushing the boundaries of creativity, and even personalizing designs.
Imagine an AI that could generate a whole new wardrobe for you, based on your own style preferences.
That's not too far-fetched. And it's not just limited to fashion either. Generative AI is being used in furniture design, architecture, even car design.
So many possibilities. It's clear that AI is having a huge impact on all sorts of creative fields.
For sure. And keep in mind, these are just a few examples from the source. There are tons of other ways generative AI is being applied out there in the world. And new applications are popping up all the time.
It feels like we've barely scratched the surface of what's possible. But before we get lost in those future possibilities, maybe we should step back and look at some concrete examples of how companies and organizations are using this technology to solve real world problems, create real value.
That's a good point. It's one thing to talk about the potential, but it's even more compelling to see how it's actually being put to work.
Exactly. Let's see this technology in action.
All right. Well, one area where generative AI is making a real difference is healthcare. The source highlights a case study where radiologists are using AI-powered tools to analyze medical images and get better at making diagnoses.
Wow, that's amazing. It seems like AI could play such a vital role in healthcare, helping doctors provide more effective and personalized care.
It really could.
Yeah.
By analyzing all that medical data, AI can sometimes spot subtle patterns in things that a human might miss.
Like a second set of eyes, but with super-powered pattern recognition.
Right. And this isn't just about radiology. They're exploring generative AI for all sorts of healthcare applications, from drug discovery to personalized treatment plans.
I can't wait to see where that leads. So, what about the entertainment industry? What's AI doing there?
Well, think about those video games you play. Generative AI is being used to create those vast, realistic worlds, design challenging levels, even generate lifelike characters that react to what you do.
It's like AI is becoming a virtual world builder.
It is, and in the film industry, they're using AI for special effects, to create those incredible backgrounds, even to synthesize dialogue for virtual actors.
Wow. It's hard to imagine what the future of entertainment will look like with AI as a creative partner.
It's going to be wild, that's for sure. And the source also mentions some interesting applications in finance, like using generative AI to analyze market trends, make predictions about what stocks are going to do.
Wait, can AI really predict the stock market?
Well, it's not a crystal ball, but it can analyze huge amounts of data,
Yeah.
identify complex patterns, make predictions based on what's happened in the past.
So it could help financial analysts make better decisions.
Right. It's about giving them more insights to work with. And the source touches on a bunch of other industries too. Marketing, manufacturing, scientific research. AI is everywhere.
It really seems like there's no limit to what this technology could do.
It's incredibly powerful. And it has the potential to reshape so many aspects of our lives.
Yeah.
Like, for example, think about content creation for marketing. AI could personalize ads, generate product descriptions, write blog posts tailored to specific audiences.
That would be amazing. But what about the potential downsides? Could this technology be used to manipulate people or spread misinformation?
That's a really important question. And it's a valid concern. AI is a tool, just like any other tool. It can be used for good or for bad. It's up to us as developers, users, citizens to make sure that this technology is used responsibly and ethically.
I agree. We need to be aware of the risks and find ways to mitigate them. We can't let the excitement of possibilities blind us to the potential dangers.
Well said. And that brings us to the final part of our deep dive. We've explored the inner workings of generative AI, seen what it can do. Now let's take a closer look at those ethical considerations. Talk about the future of this technology.
Sounds good. Let's dive in. So we're back and ready to tackle the big questions. Ethics, the future of generative AI. Where do we even begin?
Well, maybe with one of the biggest challenges, transparency.
Transparency, okay. What does that mean in the context of AI?
As these AI systems become more and more complex, it gets harder to understand how they make decisions. Like, how do they arrive at a particular output?
Right, it's like they're these black boxes, we feed in data, we get results, but we don't always know what's happening in between.
Exactly. And that could be a problem, especially when we're talking about AI being used in areas like healthcare, finance, where those decisions have real-world consequences.
So transparency means being able to peek inside that black box, understanding how the AI is thinking, so to speak.
Right. And it's not just about satisfying our curiosity. It's about building trust, making sure these systems are being used responsibly.
Because if we don't understand how the AI is working, it's hard to trust its judgment, right?
Exactly. And transparency also helps us identify potential problems, like bias in the data or flaws in the algorithms. If we can see how the AI is making decisions, we can spot those issues and fix them.
Makes sense. Transparency helps us understand the why. But what about accountability? Who's responsible when an AI system makes a mistake?
That's the million-dollar question. As AI systems become more autonomous, it gets harder to pinpoint responsibility. Is it the developer who created the system? The user who deployed it? Or Is it the AI itself?
It's a real head scratcher, especially as AI gets more sophisticated and starts making more decisions on its own.
It is a tough one. And it's a question that society is going to have to grapple with as AI becomes more integrated into our lives. We need clear guidelines, frameworks for figure out who's accountable when things go wrong.
It's like we need a whole new legal system for AI.
Maybe so.
Hmm.
But one thing's for sure, we can't just ignore the issue. We need to have these conversations and figure out how to handle these situations responsibly.
Agreed. Transparency, accountability, these are big challenges. And then there's the potential for misuse, which I know we touched on earlier.
Yeah. As generative AI gets more powerful, so does the potential for harm.
Like deep fakes, spreading misinformation.
Right. The source mentions all of that. It's a sobering thought, but we have to acknowledge those risks. Any technology can be used for good or bad.
It's like this constant tension. As technology advances, so do the potential risks.
Absolutely. But I'm an optimist. I believe that by acknowledging those risks, having open and honest conversations, we can find ways to mitigate them.
So we can still harness the power of this technology, but use it for good.
Exactly.
Mm.
And that's why ongoing research is so important. We need to keep refining these systems, make them more transparent, more robust, and find ways to safeguard against misuse.
It's like walking a tightrope, finding that balance between maximizing the benefits of AI while minimizing the risks.
A very delicate balance, for sure. And it requires a lot of collaboration, communication, researchers, developers, policymakers, the public. We all need to be involved in shaping the future of AI.
This deep dive has been truly eye-opening. We've explored the nuts and bolts of generative AI, seen some amazing applications, grappled with the ethical dilemmas. It's been quite a journey.
It has been. And I hope our listeners have enjoyed the ride.
Absolutely. To our listeners, keep exploring this world of generative AI. Ask questions, stay informed. It's a fascinating field with incredible potential to change the world.
And remember, the future of AI is not predetermined. It's something we all have a role in shaping.
So true. And on that note, it's time to wrap up this episode of The Deep Dive. Thanks for joining us. And until next time, keep diving into the depths of knowledge and discovery.